17.2 Groundwater and the water table. Prepare a sketch with labels that summarizes the distribution of water beneath Earth's surface. Discuss the factors that cause variations in the water table and describe the interactions between groundwater and streams. When rain falls on Earth's land surface, some of the water runs off, some returns to the atmosphere by evaporation and transpiration, and the remainder soaks into the ground. This last path is the primary source of practically all subsurface water. The amount of water that takes each of these paths varies greatly both in time and space. Influential factors include steepness of slope, nature of the surface material, intensity of rainfall, and type and amount of vegetation. For example, heavy rains falling on steep slopes underlain by impervious materials will obviously result in a high percentage of the water running off. Conversely, rain falling steadily and gently on more gradual slopes composed of materials that are easily penetrated by the water means that a much larger percentage of water soaks into the ground. Distribution of groundwater. Some of the water that soaks in does not travel far because it is held by molecular attraction as a surface film on soil particles. This near-surface zone is called the zone of soil moisture. It is crisscrossed by roots, voids left by decayed roots, and animal and worm burrows that enhance the infiltration of rainwater into the soil. Soil water is used by plants in life functions and transpiration. Some water also evaporates directly back into the atmosphere. Water that is not held as soil moisture percolates downward until it reaches a zone where all the open spaces in sediment and rock are completely filled with water, figure 17.5. This is the zone of saturation, also called the Phreatic Zone. Water in the zone of saturation is called groundwater. The upper limit of this zone is known as the water table. Extending upward from the water table is the capillary fringe, capillus equals hair. Here groundwater is held by surface tension in tiny passages between grains of soil or sediment. The area above the water table that includes the capillary fringe and the zone of soil moisture is called the unsaturated zone, also known as the vadose zone. The pore spaces in this zone contain both air and water. Although a considerable amount of water can be present in the unsaturated zone, this water cannot be pumped by wells because it clings too tightly to rock and soil particles. By contrast, below the water table, the water pressure is great enough to allow water to enter wells, thus permitting groundwater to be withdrawn for use. We will examine wells more closely later in the chapter. Smart figure 17.5 Water beneath Earth's surface. The shape of the water table is usually a subdued replica of the surface topography. During periods of drought, the water table falls, reducing stream flow and drying up some wells. Tutorial. Groundwater. Variations in the water table. The water table, the upper limit of the zone of saturation, is a very significant feature of the groundwater system. Knowing the water table level is important in predicting the productivity of wells, explaining the changes in the flow of springs and streams, and accounting for fluctuations in the levels of lakes. This level is highly variable and can range from 0, when the zone of saturation is at the surface, to hundreds of meters below the surface in some places. An important characteristic of the water table is that its configuration varies seasonally and from year to year because the addition of water to the groundwater system is closely related to the quantity, distribution, and timing of precipitation. Except where the water table is at the surface, we cannot observe it directly. However, the elevation of the water table is mapped and studied in detail by examining water levels in wells, figure 17.6. The U.S. Geological Survey and state agencies maintain and monitor an extensive network of observation wells to provide statistics about groundwater levels. Such data are the basis for maps that reveal that the water table is rarely level, as we might expect a table to be. Figure 17.7. Instead, its shape is usually a subdued replica of the surface topography, reaching its highest elevations beneath hills and descending toward valleys, see figure 17.5. Where a wetland, swamp, is encountered, the water table is right at the surface. Lakes and streams generally occupy areas low enough that the water table is above the land surface.
Hello, this is Callan Bentley. Welcome back for another Smart Figure. After watching this video, you should be able to describe the basic structure of groundwater and roughly what proportion of all fresh water is groundwater. So this is a pie chart over here on the left. Actually, I guess it's more like a bar chart. Showing the total fresh water in the world. Obviously, most of the world's water is in the oceans. It's not fresh. But of the water that is fresh, most of it is locked up in frozen form. It's in ice sheets and glaciers. And so of the part that's not frozen, basically, we're looking at most of it being groundwater. Okay, so the stuff that we're familiar with on the surface is only a very small part of the overall total of fresh water in the world. Around 94% of the non-frozen fresh water is underground. So what does it look like underground? Well, basically it is a pile of water that mimics the shape of the landscape above it. You'll notice here in this picture that we've got higher groundwater underneath the hills and lower groundwater underneath the valleys. Right where there's a stream at the bottom, that's where the groundwater intersects the surface. If there were a drought, then it would drop down to that dotted line and that stream could potentially dry up. Now if we zoom in on the section over here on the left, we'll notice that the groundwater occupies the pore space in a certain area below the ground. So if we take a look at that pore space that's over here, so you can see all the pore space is filled in with water in this zone right here. However, higher up above the water table, that zone is largely full of air. So the water table is this boundary that separates the zone of saturation from the unsaturated zone above it. Now we can monitor groundwater using wells, and these wells look something like the image over on the left, where we've got a little counterweight that's going down into an empty hole in the ground and a little float. As the water table moves up and down, it makes that float go up and down. That gets recorded in a little recorder box, and then it ends up getting broadcast out to a network via that antenna. So for the state of Missouri, you can see here the network of groundwater wells shown in blue. Data from one in particular, shown here in red, is depicted on this graph down at the bottom. You'll see that the water table basically was going up for a while. That probably meant rain was added. Then it dropped down very steadily over several months. That indicates relatively dry weather. Then you can see that there was suddenly a really big storm, and that big storm added a lot of water, so the water table jumped up. Then it started declining again, another big storm, and so on. So you can actually sort of get a sense of what the weather is doing by taking a look at what's happening underground. Let's think about rivers. If there were rivers flowing over this landscape, how would those rivers interact with the groundwater? Well, one possibility that you may have thought of is that the rivers get water from the groundwater. These are referred to as gaining streams, and the arrows here show that water is flowing from the groundwater into the river. Another possibility is the opposite of that. This is called a losing stream. Losing streams, there's more precipitation up on the land, but the water table is at significant depth below the surface, so water basically leaks out of the bottom of the stream. And that's an example where it's connected to the groundwater. Here's an example where it is disconnected, where it actually is sort of free falling through the unsaturated zone before it hits the water table and then spreads out into the saturated zone. Thanks a lot for your attention. This has been another Smart Figure.
Groundwater and the water table. Prepare a sketch. Figure 17.6 Monitoring the water table. Water level measurements from observation wells are a basic and important source of data. The well location highlighted in red on the map is the well whose data are shown below. Photo by Missouri Department of Natural Resources. Figure 17.7 Mapping the water table. The water table coincides with the water level in observation wells. Based on U.S. Geological Survey. Several factors contribute to the irregular surface of the water table. One important influence is the fact that groundwater moves very slowly and at varying rates under different conditions. Because of this, water tends to pile up beneath high areas between stream valleys. If rainfall were to cease completely, these water table hills would slowly subside and gradually approach the level of the valleys. However, new supplies of rainwater are usually added frequently enough to prevent this. Nevertheless, in times of extended drought, the water table may drop enough to dry up shallow wells, see figure 17.5. Other causes for the uneven water table are variations in precipitation and surface permeability from place to place. Interactions between groundwater and